To calculate the light requirement in an industrial hall, firstly, determine the lux requirement. Consider the type of work performed in the area. Consult industry standards or lighting guidelines for recommended lux levels. Common lux levels for industrial halls range from 200 to 500 lux for general tasks to 1000 lux or more for detailed work or precision tasks. Secondly, calculate the area and ceiling height. Measure the length, width, and height of the hall. Area equals length times width. Thirdly, estimate luminance in candelas per square meter. Multiply the lux requirement by a utilization factor. Utilization factors account for the geometry of the hall and the efficiency of the lighting system. Use tables or online calculators to determine the appropriate utilization factor. Fourthly, calculate lumen output in lumens. Multiply the area by the luminance value obtained in step 3. Lumen output equals area times luminance. Fifthly, select light fixtures. Choose light fixtures with appropriate lumen output and light distribution. Consider factors such as energy efficiency, maintenance, and aesthetic appeal. Sixthly, design the lighting layout. Determine the number and placement of light fixtures to achieve uniform illumination throughout the hall. Use lighting software or consult a lighting professional for optimal layout design. Now let's look at an example. Consider an industrial hall that is 100 meters by 50 meters by 10 meters. The lux requirement is 500 lux and the utilization factor is 0.7. To calculate luminance, divide the lux requirement by the utilization factor, which is 500 lux divided by 0.7, equaling 714 candelas per square meter. Then, to calculate lumen output, multiply the area by the luminance value, which is 100 meters times 50 meters times 714 candelas per square meter, equaling 3,570,000 lumens. Based on this calculation, you would need lighting fixtures with a combined lumen output of approximately 3,570,000 lumens to achieve the desired lighting level in the industrial hall. When determining the appropriate lighting for an industrial hall, several key factors must be considered to ensure optimal visibility, safety, and energy efficiency. The process involves a series of calculations and considerations that range from understanding the specific tasks performed in the hall to selecting the most suitable lighting fixtures and layout. Here's a comprehensive breakdown of how to approach this task. The first step is to accurately assess the required illuminance level, measured in lux. This is not a one-size-fits-all number, it depends heavily on the nature of the work conducted within the industrial hall. For example, a storage area might require only 200 lux, whereas a detailed assembly line could need 1000 lux or more. Industry standards and lighting guidelines, such as those provided by the Illuminating Engineering Society (IES), offer recommended lux levels for various tasks. These guidelines take into account factors such as the precision required, the contrast of the materials being worked on, and the age of the workers. Once you have a target lux level, the next step involves understanding the physical dimensions of the space. Accurate measurements of the hall's length, width, and height are crucial. The area, calculated by multiplying the length by the width, forms the basis for determining the total light output needed. The height of the ceiling affects the choice of lighting fixtures and their distribution, as higher ceilings require more powerful lights or a greater number of fixtures to achieve the desired luminance at the working plane. The luminance, expressed in candelas per square meter, is a measure of the light emitted or reflected from a surface. It's related to the lux level, but takes into account the viewing angle and the reflective properties of the surfaces in the hall. To estimate luminance, you multiply the required lux level by a utilization factor. The utilization factor is a crucial parameter that accounts for how effectively the light emitted by the fixtures reaches the working plane. It depends on several factors, including the geometry of the hall, the reflectance of the walls, ceiling, and floor, and the type of lighting fixtures used. Tables and online calculators are available to help determine the appropriate utilization factor for different scenarios. These tools typically require input such as the room dimensions, reflectance values, and fixture characteristics. With the area and lumens known, you can calculate the total lumen output needed. Lumens are a measure of the total quantity of light emitted by a light source. The calculation is straightforward: multiply the area of the hole by the desired luminance. This yields the total lumen output required to achieve the target lux level, taking into account the utilization factor. The next step is selecting the appropriate light fixtures. This involves considering several factors, including the lumen output per fixture, the light distribution pattern, energy efficiency, maintenance requirements, and cost. Different types of fixtures, such as fluorescent lamps, light-emitting diode or LED fixtures, and high-intensity discharge lamps, offer varying levels of efficiency and light quality. LED fixtures are increasingly popular due to their high energy efficiency, long lifespan, and good light quality. When choosing fixtures, it's important to consider the color temperature and color rendering index, or CRI. Color temperature affects the perceived warmth or coolness of the light, while the CRI indicates how accurately the light renders colors compared to natural sunlight. For industrial halls, a color temperature in the range of 4000 to 5000 Kelvin is often preferred, as it provides a neutral white light that enhances visibility. A CRI of 80 or higher is generally recommended to ensure accurate color perception. The lighting layout is a critical aspect of the design process. The goal is to achieve uniform illumination throughout the hall, minimizing shadows and glare. This requires careful consideration of the number and placement of fixtures. Lighting software and professional lighting designers can be invaluable in this stage. These tools allow you to simulate the lighting performance of different layouts and optimize the fixture positions to achieve the desired illuminance levels and uniformity. Factors such as the spacing between fixtures, the mounting height, and the aiming angles all play a role in the final outcome. In addition to the above steps, it's important to consider the control systems for the lighting. Dimming controls, occupancy sensors, and daylight harvesting systems can significantly reduce energy consumption by adjusting the light output based on the actual needs of the space. These systems can be particularly effective in industrial halls where occupancy patterns and daylight availability vary throughout the day. To recap, the process of calculating the light requirement in an industrial hall involves firstly determining the required lux level based on the tasks performed in the space. Secondly, measuring the dimensions of the hall to calculate the area. Thirdly, estimating the luminance by multiplying the lux level by a utilization factor. Fourthly, calculating the total lumen output needed by multiplying the area by the luminance. Fifthly, selecting appropriate light fixtures based on lumen output, light distribution, energy efficiency, and other factors. Sixthly, designing the lighting layout to achieve uniform illumination. And seventhly, considering control systems to optimize energy efficiency. Let's delve deeper into each of these steps. Determining the lux requirement. The lux requirement is the cornerstone of any lighting design. It specifies the amount of light needed on the working plane to ensure adequate visibility for the tasks being performed. As mentioned earlier, the recommended lux levels vary widely depending on the nature of the work. General tasks such as storage, handling of bulky materials, and passageways typically require lower lux levels in the range of 200 to 300 lux. More demanding tasks such as assembly lines, inspection areas, and machine shops may need 500 to 1000 lux or more. Precision tasks such as electronics assembly or quality control can require even higher levels, up to 2000 lux. When determining the lux requirement, it's essential to consider the age of the workers. Older workers typically need higher illuminance levels to achieve the same level of visibility as younger workers. The IES guidelines provide adjustments for age, suggesting higher lux levels for workers over the age of 55. Another factor to consider is the reflectance of the materials being worked on. Darker materials require higher illuminance levels to provide sufficient contrast and visibility. The IES guidelines also provide adjustments for material reflectance. Calculating area and ceiling height. Accurate measurements of the hall's dimensions are crucial for calculating the area and determining the appropriate lighting layout. The length and width of the hall are used to calculate the area, which is a key input for determining the total lumen output needed. The height of the ceiling affects the choice of lighting fixtures and their distribution. Higher ceilings require more powerful lights or a greater number of fixtures to achieve the desired illuminance of the working plane. The height also affects the utilization factor, as more light is lost due to absorption and scattering in larger spaces. Estimating luminance. Luminance is a measure of the light emitted or reflected from a surface, taking into account the viewing angle and the reflective properties of the surface. It's related to the lux level, but provides a more complete picture of the perceived brightness. To estimate luminance, you multiply the required lux level by a utilization factor. The utilization factor accounts for the efficiency of the lighting system and the geometry of the hall. It depends on several factors, including the reflectance of the walls, ceiling, and floor, the type of lighting fixtures used, and the layout of the fixtures. Tables and online calculators are available to help determine the appropriate utilization factor for different scenarios. These tools typically require input such as the room dimensions, reflectance values, and fixture characteristics. The reflectance values of the walls, ceiling, and floor play a significant role in the utilization factor. Lighter surfaces reflect more light, increasing the overall illuminance and reducing the amount of light needed from the fixtures. Darker surfaces absorb more light, requiring higher lumen output from the fixtures to achieve the desired illuminance. Calculating lumen output. The total lumen output needed is calculated by multiplying the area of the hole by the desired luminance. This yields the total quantity of light required to achieve the target lux level, taking into account the utilization factor. The lumen output is a key parameter for selecting the appropriate lighting fixtures. Each fixture has a rated lumen output, which indicates the amount of light it emits. By dividing the total lumen output needed by the lumen output per fixture, you can determine the number of fixtures required to achieve the desired illuminance. Selecting light fixtures. The selection of light fixtures is a critical step in the lighting design process. It involves considering several factors, including the lumen output per fixture, the light distribution pattern, energy efficiency, maintenance requirements, and cost. Different types of fixtures offer varying levels of performance in each of these areas. Fluorescent lamps have been a traditional choice for industrial lighting due to their relatively high energy efficiency and long lifespan. However, they are gradually being replaced by LED fixtures, which offer even greater energy savings and longer lifespans. LED fixtures are also more versatile in terms of light distribution and control. They can be designed to provide a wide range of beam angles, allowing for precise control of the light pattern. This is particularly useful in industrial halls where specific areas may require higher illuminance levels than others. High-intensity discharge lamps, such as metal halide and high-pressure sodium lamps, are another option for industrial lighting. These lamps offer high lumen output and are suitable for large spaces with high ceilings. However, they are less energy efficient than LED fixtures and have longer warm-up times. When selecting light fixtures, it's important to consider the color temperature and color rendering index, or CRI. Color temperature affects the perceived warmth or coolness of the light, while the CRI indicates how accurately the light renders colors compared to natural sunlight. For industrial halls, a color temperature in the range of 4000 to 5000 Kelvin is often preferred, as it provides a neutral white light that enhances visibility. A CRI of 80 or higher is generally recommended to ensure accurate color perception. Lighting layout. The lighting layout is a critical aspect of the design process. The goal is to achieve uniform illumination throughout the hall, minimizing shadows and glare. This requires careful consideration of the number and placement of fixtures. The spacing between fixtures, the mounting height, and the aiming angles all play a role in the final outcome. Lighting software and professional lighting designers can be invaluable in this stage. These tools allow you to simulate the lighting performance of different layouts and optimize the fixture positions to achieve the desired illuminance levels and uniformity. The spacing between fixtures is typically determined based on the mounting height and the light distribution pattern of the fixtures. A general rule of thumb is that the spacing should be no more than 1.5 times the mounting height to ensure uniform illumination. However, this can vary depending on the specific characteristics of the fixtures. The aiming angles of the fixtures can also be adjusted to optimize the light distribution. In some cases, it may be desirable to aim the fixtures directly downward to provide maximum illuminance on the working plane. In other cases, it may be preferable to aim the fixtures at an angle to reduce glare and improve uniformity. Control systems. Control systems can significantly reduce energy consumption by adjusting the light output based on the actual needs of the space. Dimming controls, occupancy sensors, and daylight harvesting systems are all effective strategies for optimizing energy efficiency. Dimming controls allow you to adjust the light output of the fixtures based on the time of day or the specific tasks being performed. This can be particularly useful in areas where the luminance requirements vary throughout the day. Occupancy sensors detect the presence of people in the space and automatically turn the lights on or off. This can be a simple and effective way to reduce energy consumption in areas that are not constantly occupied. Daylight harvesting systems use sensors to detect the amount of natural light available and adjust the light output of the fixtures accordingly. This can be particularly effective in areas with large windows or skylights. In conclusion, calculating the light requirement in an industrial hall is a complex process that involves several steps. By carefully considering each of these steps, you can design a lighting system that provides adequate visibility, enhances safety, and optimizes energy efficiency. The key is to understand the specific needs of the space and select the appropriate lighting fixtures and control systems to meet those needs.